So consider a 238 turn coil. We have its diameter. It's placed in a spatially uniform magnetic field. We know the magnitude of the magnetic field. And the magnetic field is perpendicular to the surface. So B dot dA or B dot n hat dA is going to be just B times the area. Find the magnitude of the EMF induced in the coil. The magnetic field is reduced to 0 uniformly in 1.84 seconds. So first of all, we're dealing with the magnetic flux, right? So that's going to be this integral over the surface of B dotted with n hat dA, right? And we know, all right, we know a couple of things, that magnetic field is uniform over that surface, and we know that it's perpendicular to that surface, so this just ends up being BA, right? Just ends up being BA. Where A is the area, right? We know the area. Oh, why did that end up there? We know the area because that's just pi, and we're given the diameter. Okay, diameter over 2 squared, right? So we know the area, we know the magnetic field, and what we're after, see if I can delete that real quick. Oop. What we're after is the EMF, right? So the EMF, pause. Okay, sorry about that. Now that I've remembered how to type a script to here, looked up, be more appropriate. So the electromagnetic force, right, is minus the number of turns onto the derivative of the magnetic flux with respect to time, right? Derivative of the magnetic flux with respect to time. And we know N, and we know d phi, right? We're talking about this equation right here, right? We know N, we know d phi m dt. Why? Well, since it is changes uniformly over time, this is just whatever our magnetic flux is at the end, final, minus our magnetic flux at the beginning, initial, right, over time, since it changes uniformly. And this ends up being magnetic flux at the end is 0, right? So this is just going to be minus onto a minus, so it's going to be plus n onto our magnetic flux to begin with, divided by the amount of time it takes, which is just n onto BA over the time, right? N onto BA over the time. And it asks for the magnitude, so we're not really concerned about the details of the minus sign, and actually we don't have enough information to assign a sign to this, because you'd have to know directions and things like that we don't know. So this is how you get there on this problem, little magnetic flux problem.